Hello everyone and welcome to PadhaiX. In this video, we'll solve NCERT Class 11 Physics question 3.19 from the chapter Motion in a Plane. So let's first read the question carefully. Question 3.19. The vectors I and j are unit vectors along the x-axis and y-axis respectively. What are the magnitude and direction of the vectors I plus j and I minus j? What are the components of the vector a2i plus 3j along the directions of I plus j and I minus j? Now that we've understood the question, let's solve it step by step.
First, let's draw the coordinate system with the x-axis and the y-axis. Here, I is the unit vector along the positive x-axis and j is the unit vector along the positive y-axis. Since both are unit vectors, the magnitude of I and j is 1 unit. Now, let's solve the first part of the question, where we need to find the magnitude and direction of the vectors I plus j and I minus j. Let's begin with I plus j. To add these two vectors, we'll use the parallelogram method. We have already drawn both vectors from the same origin. Next, draw lines parallel to each vector to complete the parallelogram. The diagonal passing through the common origin represents the resultant vector, I plus j.
Now, let's calculate its magnitude. Since the horizontal component is 1 and the vertical component is also 1, we can apply the Pythagoras theorem. The magnitude of I plus j is equal to the square root of 1 squared plus 1 squared, which gives us square root of 2. Next, let's find its direction. Suppose the vector makes an angle theta with the positive x-axis. Using the tangent ratio, tan theta equals perpendicular upon base equals 1 upon 1 equals 1. Therefore, theta is equal to 45 degrees. So, the vector I plus j has a magnitude of root 2 and it is directed at an angle of 45 degrees with the positive x-axis.
Now, let's move on to the vector I minus j. Subtracting j is the same as adding minus j, which is a unit vector directed downward along the negative y-axis. Again, we'll use the parallelogram method. We have already drawn the vectors I and minus j from the same origin. Now, complete the parallelogram. The diagonal represents the resultant vector, I minus j. Let's calculate its magnitude. The horizontal component is 1. While the vertical component is minus 1. Applying the Pythagoras theorem, the magnitude becomes the square root of 1 squared plus minus 1 squared, which is again square root of 2.
Now let's determine its direction. Let the angle made with the positive x-axis be theta. Using the tangent ratio, tan theta equals minus 1 upon 1 equals minus 1. Hence, theta is equal to minus 45 degrees. This means the vector I minus j has a magnitude of root 2 and it is directed 45 degrees below the positive x-axis or minus 45 degrees with respect to the positive x-axis. And with that, we have completed the first part of the question. In the next part, we'll find the components of the vector a equals 2i plus 3j along the directions of I plus j and I minus j.
Now, let's move on to the second part of the question. We need to find the component of vector A along the direction of vector I plus j. First, let's draw vector A. Notice that vector A has a horizontal component of 2 units along the positive x-axis and a vertical component of 3 units along the positive y-axis. Now, to find the component of A along I plus j, we'll first draw a line in the direction of the vector I plus j. Next, from the tip of vector A, draw a perpendicular to this line. The pink vector obtained along the direction of I plus j represents the component of vector A along I plus j. Now, let's calculate this component mathematically.
The component of a vector A along another vector B is given by the dot product of A and B, divided by the magnitude of vector B. So, the component of A along I plus j can be written as vector A dot vector I plus j divided by the magnitude of vector I plus j. Substituting the values, vector A is 2i plus 3j, and the second vector is I plus j. So we have the dot product of 2i plus 3j with I plus j divided by the magnitude of I plus j. Now, let's expand the dot product. this becomes 2 times I dot I plus 2 times I dot j plus 3 times j dot I plus 3 times j dot j.
Since I and j are mutually perpendicular unit vectors, I dot j equals 0, j dot I equals 0, and I dot I as well as j dot j are both equal to 1. Therefore, the expression simplifies to 2 plus 3 divided by root 2, which gives us 5 upon root 2. Hence, the component of vector A along the direction of I plus j is 5 upon root 2 units. This completes the second part of the question. In the next part, we'll find the component of vector A along the direction of I minus j.
Now, let's find the component of vector A along the direction of vector I minus j. We'll follow the same procedure that we used in the previous part. The pink vector obtained along the direction of I minus j represents the component of vector A along I minus j. Now let's calculate this component mathematically. The component of A along I minus j can be written as vector A dot vector I minus j divided by the magnitude of vector I minus j. Substituting the values, vector A is 2i plus 3j and the second vector is I minus j. So we have the dot product of 2i plus 3j with I minus j divided by the magnitude of I minus j, which will become equal to 2i times I plus 3j times minus j divided by under root of 1 square plus minus 1 square equals to minus 3 divided by root 2, which gives us minus 1 upon root 2 units. And with this, we have successfully solved NCERT Class 11 Physics question 3.19. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to PadhaiX for more NCERT physics solutions. Thank you for watching, and I'll see you in the next video where we'll solve question 3.20.